Hey class, this is section 1.6 and we are solving quadratic equations. So let's see how we're going to do these. The first one, they want us to do it by completing the square again. So what we can do is follow the same steps. Step number one is to make sure that the leading coefficient is 1, which it already is. Step 2 is to move the c term to the other side. So let's do that by subtraction. So we have x squared plus 23x space equals negative 22. Step 3 is to find the missing term. And remember, the way we do that is we take our b term, divide it by 2, and square that. So our b term is 23 divided by 2 squared. This time, 23, 2 does not go into 23 evenly, so we're just going to have to leave it as a fraction and square that. So 23 squared is 529. 2 squared is 4. So that's what we're going to add to both sides of the equation. 529 over 4. 529 over 4. The next step is to factor the trinomial. It's going to be a perfect square, remember? So in this case, we know that x squared breaks up into x times x. We have to figure out how this breaks up. Here's a little shortcut. Whatever you get inside of the parentheses before you square, that's going to be what it breaks up into. So this would break up into x times x. This would break up into 23 over 2 times 23 over 2. If you multiply these two fractions, you get that. And so that's going to give us these other two numbers that we need. And because this is a plus, that means both of these are going to be pluses as well. Now we need to add these two terms. So let's get a common denominator, which is going to be 4 times 4 times 4. That's negative 88. Negative 88 plus 529 is 441. So that's what we have on the right side. Let's write this as a perfect square binomial. Right? To get rid of the square, we take the square root of both sides. That cancels the square out. And now we're left with x plus 23 over 2 equals plus minus. Let's check to see if 441 is a perfect square. Square root of 441 is 21. It is. And the square root of 4 is 2. All right, the next step is to subtract 23 halves to both sides. And that leaves us with x equals negative 23 halves plus or minus 21 halves. So here we have to separate the plus and the minus. So let's do the plus first. Negative 2/3, 23 halves plus 21 halves is going to be negative 2 over 2. Which is negative 1. Now we do the subtraction. This number minus this number, that means we're going to add them because they're both negative, so that's going to be negative 44 over 2, which is negative 22. So the two answers are negative 1 and negative 22. The next problem is the same instructions. Completing the square. This time there is a leading coefficient that is not equal to 1. So our first step is to divide that number out. Because you always need a 1 there. So that becomes x squared plus 7 halves x plus 2 equals 0. Our next step is to move the c term over by subtraction. X squared plus 7 halves x blank equals negative 2. Then the next term is to complete this, find the missing term. So we need to take the b term and divide it by 2 and then square it. So here's our b term. It's a fraction. So you're going to have 7 halves divided by 2 squared. Well, dividing is the same thing as multiplying by the reciprocal, so we could put a 1 under here. And now we're dividing two fractions, which means we're really multiplying by the reciprocal, which is 7/4 squared which is 49/16. So that is a number that we're going to add to both sides of the equation. All right, and then the next step becomes factor the left side into a perfect square binomial. So remember that shortcut I taught you, it's x times x for that term. And for this term, if you want to break that up, it's going to be whatever's in the parentheses before you square it. So it's going to be 7/4 times 7/4. As you can see, 7 times 7 is 49. 4 times 4 is 16. And because this is a plus, that means these two have to be positive as well. Plus 7/4 plus 7/4. Over here on the right side, we have to find a common denominator, which is 16. Multiply top and bottom by 16. You get negative 32 plus 49, which is 17. So we end up with 17/16. Rewriting this becomes x plus 7/4 to the second equals 17/16. Taking the square root of both sides gives us x plus 7/4 equals plus minus. Don't forget the plus minus. 17 is not a perfect square. However, 16 is. 16 becomes 4 when you take the square root of it. And then our final step is to subtract 7/4 to both sides. So x equals negative 7/4 plus or minus radical 17/4. Notice you have a common denominator, so I would combine those two fractions into a single fraction, just like that. And of course, we need to write the answers separately for WebAssign to accept it. So one answer would be negative 7 plus radical 17/4, comma, negative 7 minus radical 17/4. That would be the two solutions. Let's take a look at the next example. This time they say find all the real solutions, which means you can use any method you like. I always recommend the quadratic formula. I think it's a little easier than completing the square, but if you like completing the square, you're more than welcome to do it that way. Or you can even try factoring. I'm going to go ahead and plug in these values. So negative 4 plus or minus 4 squared minus 4 times 2 times negative 5 all over 2 times 2. Negative 4 plus or minus, that's going to be 16 plus. Notice I put plus because there's a double negative there. 4 and 5 is 20 times 2 is 40 over 4. So that's going to be negative 4 plus or minus square root of 56/4. Square root of 56, can we simplify that? I think we can. We can divide by, there's a factor of 4 in there. So we can break that up into 4 times 14. And then the 4 becomes a 2 on the outside. So now we have negative 4 plus or minus 2 radical 14/4. Careful not to cancel these two out. You can't do that because of this plus minus, but what you can do is you can take out a GCF. The common factor of the numerator is 2. So if you take out a 2, you're left with negative 2 plus or minus radical 14/4. Notice what I did is I factored out a 2 from here, and I factored out a 2 from here. And now I can simplify these two. 2 and 2 goes into 2 once, 2 goes into 4 twice. And that would be our final answer there, which is negative 2 plus or minus square root of 14 all over 2. To write that, you need to separate the two terms, or the two solutions, one plus and the other minus. All right, this next problem down here says find two numbers whose sum is 42 and whose product is 341. So I would recommend creating two equations. X plus y are the two numbers that we're looking for. We know that the sum is 42, and the product, x times y, has to be 341. So now what we can do is we can solve for either x or y and then do substitution. I'm going to solve for y. Doesn't matter though. So if you solve, you're going to get y equals 42 minus x, and then you would substitute into there. And so this is going to be x times 42 minus x equals 341. I substituted there. Now I need to distribute and solve this quadratic equation. So we have 42x minus x squared equals 341. And notice I have a quadratic. So I want to make one side equal to 0. I'm going to bring these two terms over to the right side. So if I do that, I'm going to get we should get 0 equals x squared minus 24x plus 341. And so now we have an equation that we need to factor. So let's see if we can do that. This one should be a little bit challenging because this number is very large. So what we can do is, what I would recommend is just kind of look up here and see if you can figure out which two numbers has a sum of 42 and a product of 341. So I'm going to just do some guess and check. I'm going to try 20 and 22. That's very close, but nope. How about 18 and 24? No, that's not going to work. Let's try some smaller numbers. How about 15 times No, we're going to have to try smaller. How about 12 times? So I'm getting closer. How about 10 times 32? No, let's try 11 times. All right, I think we found it. It should be 11 times 31. If you try 11 times 31, you're going to get 341, which is exactly what we needed. And if you do 11 plus 31, you're going to get 42, which is exactly what we needed. So we found the combination of numbers that is going to make this work out. It's going to be negative 11 times negative 31. And that's going to make positive 341. So now if you set each of these equal to 0 and solve, you're going to get 11 and 31. All right, so that is our final answers, 11 and 31. I suppose you didn't really need algebra to do this, but it's nice to know how to do it algebraically. You could have just done guess and check like I did until you eventually got the two numbers. But it's always nice to be able to do a little algebra to solve. Let's look at the final page. This one says it took a crew 3 hours and 9 minutes to row 9 kilometers upstream and back again. If the rate of flow of the stream was 3 kilometers per hour, what was the rowing speed of the crew in still water? So for these kind of problems, I like to draw a table. We got rate, time, and distance. And then we have two directions. We have upstream and downstream. Downstream. All right. So let's see if we can fill out these boxes here. It took a crew 3 hours and 9 minutes to row 9 kilometers upstream. So it looks like the distance is 9 kilometers. So we can fill that in, distance. And it's the same distance going back. All right. If the flow of the stream was 3 kilometers per hour, well, we know when we're going upstream, it's the rate of the boat minus the current. When we're going downstream, it's the rate of the boat plus the current. So that would be the rate for each of these two. So let's see. The rate is unknown, but the speed of the current is known. So it's going to be r minus 3 for this one and r plus 3 for that one. For the time, it tells us that it took 3 hours and 9 minutes. So let's see if we can do that. So 3 hours and 9 minutes to row upstream and back again. All right, so up and back, that's going to be a total of, let's see if we can figure this out. Well, we know that rate times time is equal to distance. So therefore, time is equal to distance over rate. So in order to fill out these two boxes, all you got to do is divide distance and rate. So distance divided by rate. So that would be 9, which is the distance, divided by the rate. And here the distance divided by the rate. And now we know that the total time was 3 hours and 9 minutes, but we need to convert that to hours. So 9 minutes in hours would be 9 out of 60. So that's going to be 3 hours and 9 9/60ths of an hours. So I converted the minutes into hours by dividing by 60. All right, so now we can multiply and then add. So that's going to become, actually we can simplify this fraction by 3. It's going to be 3 and 3 over 20. All right, so that becomes, if you convert that to an improper fraction, that's 63 over 20 hours total. So what I did is I converted this time into hours by converting minutes into hours, 9 over 60. Then I simplified this fraction by 3, and then I converted this mixed number into an improper fraction. So the total time has to equal this. So in other words, 9 over r minus 3 plus 9 over r plus 3 must equal 63 over 20. The total time has to add up to that amount. Now, in order to solve this, we need to multiply both sides of the equation by the lowest common denominator, which is 20r minus 3r plus 3. 20r minus 3r plus 3 is the lowest common denominator. Distribute. Here, these two factors will cancel. We'll be left with 20 times 9 times r plus 3, which is 180 r plus 3. For the next one, these two cancel. We're left with 180 once again times r minus 3. And over here we got these two canceling out. And so now we're going to have, we might as well FOIL this out because we're going to need to do that anyways. That's going to be r squared minus 9. So we have 63 r squared minus 9. All right, now we have this equation that has some large numbers. Let's see if we can solve it. Well, I'm noticing something. I'm noticing that 63, 180, and 180 share a common factor of 9. So why don't we divide out the 9 to make these numbers a little smaller? So that's going to be 20 r plus 3 plus 20 r minus 3 equals 7 r squared minus 9. So that helps out a little. Now we can distribute. So we got 20r plus 60 plus 20r minus 60 equals 7r squared minus 63. All right, luckily for us, something cancels. So we do have 40r over here if we combine those like terms. And then we can subtract the 40r over. Finally, we end up with this equation over here, which is going to be 0 equals 7r squared minus 40r minus 63. All right, at this point, we want to try to factor. Let's see if we can factor this. I'm going to try the guess and check method. So I'm going to do 7r times r, and I'm going to try 9 times 7. Let's see, that's 9 and 49 will make negative 40. If you make this term negative and this term positive, you will get negative 40, I'm sorry, you will get inner is 9r, negative 49. If you combine those, you get negative 40. So it works out. Now we can solve 7r plus 9 equals 0, r minus 7 equals 0, r equals negative 9/7, or 7. Notice that this represents the speed of the boat. A speed of the boat cannot be negative, so it's got to be 7 miles per hour in still water. So that is the final answer. Kilometers per hour, sorry. That was a whole lot of work. All right, let's look at this last example. So it says a fish population in a certain lake rises and falls according to this formula. F represents the number of fish at time t. T is measured in years since the date January 1st, 2000, when the fish population was first estimated. On which date will the fish population again be the same as it was on January 1st? Well, on this date, that's time equals 0, because that's when the model begins. That's the reference point of when this starts. So if we plug in 0 for t, this becomes 0, 0. You're left with these two numbers. And if you multiply that, at time equals 0, the fish population is going to be 2,000 times 23, which is 46,000. So we're looking for when is the fish population going to again become 46,000, because it's telling us that the number of fish is rising and falling. So it's going to rise and it's going to hit 46,000, and then it's going to go back down again. So at some point it'll be 46,000 at two different times. One time is at 0 and the other time is what we need to find. So in order to do that, you want to set the fish population equal to 46,000 and rewrite the equation as you see it up there. Now we can distribute. So the fish population, we need it to be 46,000, and this is the right side of the equation. We got to solve for t. So this becomes actually, what I recommend, instead of distributing, that's going to just make the numbers really large. Instead of distributing, what we can do is we can just divide both sides by 2,000. That'll make our lives a lot easier. So if you divide that out, you're just going to get 46 divided by 2, which is 23. Now that's much easier to deal with. And now you could subtract 23 to both sides, and you will get 0 equals 11t minus t squared. We take out the common factor, which is t, and you have two factors to solve for. T equals 0, which we already knew, and t equals 11. So remember, this represents the number of years since January 1st, 2000. So the date would have to be January 1st, 2011. Because we take this number and we add it to the year. All right, so that's what would go here, January 1st, 2011. All right, the final question is asking, by what date will the fish in the lake have died? In other words, when is the population of the fish equal to 0? So we set that equal to 0. And similarly, instead of distributing like we almost did last time, it's better or easier to divide both sides by 2,000 again. And you're going to get 0 equals 23 plus 11t minus t squared. Unfortunately, this is not factorable, so we will have to do the quadratic formula. I'm going to divide out a -1 because I always like to deal with equations that have a positive quadratic. So if I divide out a -1, you're allowed to do that. That's going to be 0 equals positive t squared minus 11t minus 23. Now we can do the quadratic formula, -b plus or minus b squared minus 4ac all over 2a. So this is going to be, notice once again, double negative makes a plus. So 4 times 1 times 23 is going to be 92. And then 121 plus 92 is 213. So I'm going to have to work up here. 11 plus or minus square root of 213 over 2. So let's go ahead and just find the decimal. Since we're looking for a date, we can just find the decimal. So let's do the plus first, and then we'll do the minus second. So 11 plus the square root of 213 is equal to 25.59 divided by 2. It's going to be approximately, t is equal to approximately 12.8. Now let's do the minus. 11 minus square root of 213 divided by 2. That's going to be negative 1.79, or actually 1.80 if you round. But they don't really want you to go back into time. They want you to go forward. So this one would take you back. This one would move you forward. So this one is out. This is the year that they want. The earliest date would be, the year would be, would have to be 12 years, 12 and some change. So let's just go with 13 years later. So I would say about, well, actually, let's just go with the 12 years. So 2012. So that concludes this section.